So we are working on the finite loop. So as I mentioned earlier, for the finite loop, we're actually following the for loop structure, right? Whereby you have the loop counter, you have a condition, and each time of the loop has lapsed, we want to increase the content of the loop counter by 1. So whenever you want to construct a finite loop, two things that you need to always take into consideration is the loop counter and also the loop limit, which sets as a condition for your loop. So here you can see there are two types that you can actually have the finite loop structure. So I here is actually your loop counter, and I with the subscript 1 is that you are initializing the I. So same thing that you actually see here. You are initializing the I. So you always have the initialization, then you have the loop limit where you set the condition, and of course you increment. So the same structure is what you are seeing here. So the first part here is initializing I, and then you're checking with the condition. Is I less than I2? So what is this I2? Is your limit. You're setting a condition. And then you're doing your particular task. After you have done your particular task, you increment the loop count by 1, indicating that one time you have already done this, your task. So after you've done so, you check back with the limit. Has it exceeded the limit? As long as it's not exceeded the limit or the condition holds true, it'll keep on executing the task and increase your counter by 1 until the point where it no longer holds true. It will exit from the loop. So in this way you can actually create a finite loop. And likewise, the other way that you can do is you can initialize the value and then you can decrease the value. So there are two ways that you can do. One, you can start from 0 and you keep on increasing until reaching the limit, or you can start with the limit value and then you keep on decreasing until it reaches 0, for example. So both ways are fine. So there are many other structures of actually doing this, but I'm going to show you one of the easiest way of doing this. So there are few instructions that comes in handy whenever you want to use this finite loop structure. Earlier we have used branch. So this branch n, there's no condition. It doesn't set any condition. There are also some other branch instructions which comes with condition. Branch if the carry is 1, branch if it's negative, branch if it's non-negative, branch if there's overflow, branch is the result is not 0, or branch if it's 0. So we can use any one of these, branch if it's not 0 or branch if it's 0. And then there are instructions that we can combine or use, for example, like goto. So this goto works same as branch. The only thing is goto is the 32-bit instruction. It's a 32-bit instruction, which means it is the same as branch. The only thing, branch allows you to go 1023 steps positive and 1024 steps negative. Whereas goto instruction, if you refer back to your chapter 1 notes, it is a 32-bit instruction, which means it allows 500 steps positive and negative 500,000 steps negative, which means it covers the entire program memory. Remember, when I say 5,000 steps, if you times 2, it's already 1 million, right? Steps. Do you recall steps? One step is equivalent to 2 memory locations, right? So your goto can go 500 steps positive, can go 500 steps negative. So if you times 2, that is 1 million, 1 million, it is 2 million. So which means goto instructions can reach to any point in program memory. So but it works the same as branch. Branch it has a limitation. It can only go 1023 steps up and negative 1024. So if you write a code which is extremely long, let's say assume you write a code, start, then you write all the code, you write so many thousands of lines of code, and then at the bottom you put branch to start. If it's exceeded the 1023 steps, it will give up an error telling that the range is it is out of range. So it can't detect because it's already more than 1023. But never worry, because you will never write a code that long. So in this case, you can either use goto or branch. Branch both works exactly the same. So branch is 16-bit, goto is 32 bits. Got it? And then there are also some instructions that we will be using. For example, decrease file register. This decrease file register and also increase file register. And there are some instructions, like for example, decrease file register skip if 0, and decrease file register if it's not 0. So these are one of the popular one which I would like to use for a finite loop structure. So let us see how we can actually try to, first we'll just take this one example. We'll try to construct a loop just based on this flowchart, and then I'll show you one of my favorite loop structure for finite. Is that okay? So we'll take the same example. So I'll just remove all this. So let's say we try to follow exactly what's in the chart. So before that, we need to define two things, right? We need to have the loop count and also the loop limit. So here we can have our assembler directives, whereby we can have our loop, maybe I name it as loop count, our loop counter. Our loop counter, is it a value or is it a register? Remember, we have two things. We have loop counter and we have the loop limit. What is loop count? Is it a register? It's a container, right, to hold the value of how many. So it should be a register. So you use EQU or set? You set, because you want to assign an address to it. So let's say if we assign address hex 00, and then we have the loop limit. So let's say in this case we just want the loop to loop 5 times. So the loop limit, is it a register or is it a value? It's a value. So you use set or EQU. So you use EQU and put 5 times. Is that okay? Any question up to this point? So this is actually our I, and this is our I2, which is the value. Why am I writing like this? So that you can correspond with this. So first thing is you want to initialize I. So I1 is, you can set as 0. That means you want to start from 0. So how can you make it 0? Yes, you can use instruction clear F. Which register that you want to clear? Loop count. Clear F has how many fields? Check in your instruction set about how many fields. Does it have FA or FDA? FDA or FA. It only has FA. So first thing you do is you clear. Second is here you have this condition here. This is what we can do is, instead of using equals to, now here's some small trick. If you use less than, how many times will the loop go? 0, 1, 2, 3, 4, 5 times. Because you start from 0, and if you say if I is less than 5, you will achieve the 5 times loop. If you are starting from 0, and then you put less than or equals to 5, then it will execute 6 times. So just to avoid the confusion, if let's say now our aim is what, to make the loop 5 times. So if you want to loop it 5 times, of course the loop limit is 5. So if you are going to initialize it to 0, always use the condition less than. If you are going to initialize it to 1, then you can use less than or equals. Is that okay? Any question up to this point? So I'm going to use less than. I'm not going to use less or equals. Now this one is a condition where we check if it's less than. So these instructions allow us to compare between the file registers. So we have 3 compare instructions. Compare file register, skip if equal. Compare file register, skip if greater than. Compare file register, skip if less than. Come again? We don't. We don't have that instruction. But that is okay, that is fine. So, whenever we say compare file register, skip if greater than, and FA, so what it actually means is you're comparing the file register with the content of working register. So that you need to be very clear. And also, so how would you write this? Compare file register with working register. Skip. This S stands for skip. If file register is greater than working register. So if you want to write it down, it looks like if the content of file register is greater than working register, then you skip. Is that okay? The same thing with if less than. So you always put your file register on the left hand side and the content of working register on your right hand side, and the condition here. So what this means, compare file register with working register, skip if the content of file register is less than working register. So that's what it means. Now another thing that you need to note, that these compare instructions always come with a double pair. It always comes with a double pair. The first pair is, before you use the compare, always you need to move literal value. Why we need to move literal value? Because we need to load the limit into working register. And then another pair is, either you can use with go to or you can use branch. So it always has this double pair. So it never comes alone, always comes with move LW, compare, and then you have branch or go to. It always comes like that. So to show you how this is being used, here in this case, which instruction that we want to use? So we have skip if greater than, skip if less than, skip if equal. There are 3 compare instructions. Are we going to use skip if equal? Nope. You have skip if greater and skip if less than. So which one do you want to use? Skip if greater. Okay. So we are done with this part. Now we want to do this compare part, right? So always remember, compare comes with double pair. So we said compare file register skip if greater than. So they all said right. So here what are we comparing? Your loop counter, what is I2? Your loop limit, right? So here, because it has F and A, here you are comparing loop count with working register. So remember it comes to the double pair. So what you have to move into working register? Yes, you have to load the loop limit. So then only you can compare, right? That's why I said always comes with the double pair. So this is confirm always, because you are comparing the content of file register. So here what you're doing is, actually you're checking if the content of loop count, if it's greater than the content, greater than your loop limit value. If greater, what do you do? Skip. I will explain to you what it means by skip. So you all follow up to this point? So currently what is the content of loop count in the first round? 0. What is the value of loop limit? 5. Is it larger than 5? No. So will it skip? No, it won't. Later I am just following whatever you say, so we will see what happens. So will it skip? No. So what it means by skip is, currently this is the line of the instruction, right? By right, the next instruction is supposed to be here, this line. Skip means it will skip to the next line. It will skip one line, that's what it means. So in this case, if it's skip in this sense means what? Is it a yes or no? It's actually yes. Compare if this is greater, if this is greater, then it's supposed to go out of the loop. Currently this is 0 and this is 5, and it will only skip if this is larger than 5. So currently it is not, so will it skip? No, it won't skip. So it will go here to the next line. So what is supposed to do if it's not skipping? It's supposed to do the task, right? So let's say the task is something same like our wait, we can use, never mind, I'll use this. Oh, never mind. INCF extend. I say this is the task that you want to do. So after you do the task, what is the next thing you're supposed to do? Increase the count. So what is the instruction that you can use to increase the count? You can use the increase F loop count F A. So don't get confused with this one and this one. Huh? This is our task. So I'm just choosing an increase instruction to increase the content. So after you have performed, you have to increase the loop count by 1. After you increase the loop count, what is this? This is what? Yes, repeating. What instruction is this? Do you have any condition? No, it doesn't, right? So you can branch, you can put any name. Where should this repeat go? you should go back to either here, or you can straight away go here. Why you can straight away put here? Because the other instruction is not disturbing the content of working register. But just to be on the safe side, to have this proper habit, better to put here. Is that okay? Anything that you want to change? So I'll put NOP here. Okay, so this one, what we have done is only one side of the condition, which means skip. Yeah, that's why I just missed that. Okay, so because we use this skip if greater, it becomes a bit complex in the sense that this is when this compare instruction, they always have two outcomes, right? One is yes and one is no. So in this case, if it's yes, it will supposed to do the task, supposed to increase and branch repeat. This is what it's supposed to do. If it's not, it will skip. But skip only, it can only skip the one line. So it actually disturbs this flow. So we have to make a bit of modification. So here we can have the first branch, and here we'll have the second branch. Skip if greater than. If this condition no longer holds true, it will skip. Skip means it will go here. The skip means it's already out of the condition, so you have to exit right. So maybe you can put branch, exit, and where can the exit go? Can go to the here NOP. It'll go out. If it's not, it's supposed to do this one, this one, this one, this one. So we can put continue. Where should it continue? Here. So this compare always will have two outcomes. Is this okay? Any question on this? So if you execute this, let's see how many times it actually loops. It actually loops 6 times. Why? Because of this condition. So if you want to loop it 5 times, what you should do? You can actually either load this value from 1, or you can put here skip if equal, or you can put skip if less than. So let's see, just for the sake of showing you all. Let's view the file register so we can actually see. Okay, so when you press F7, okay, currently the loop count at this address, so it is actually 0, and you're comparing with working register. So let us also watch the working register. So of course the working register now is actually already loaded with the value 5. It's loaded with 5 because of this line. Next, you're going to compare. Currently, the loop count is at address 00. You're comparing So where do you think the green arrow will go? First branch or second branch? So it is going to the first branch because it is not greater than 5. Then you increase the content. This is our task. Our task is to increase the content. Then when you run again, it will also increase the content of loop count. And it will branch repeat. So again, so 2, 3, 4, 5, 6. Now the content of loop count is 6. Now only it will go to branch exit. So it is 6 times, not 5 times. When you use, say, this is sometimes when you use the different condition, it changes. So what if you use less than? Skip if less than. Any question up to this point? So what happens if you use less than? So if you use skip if it's less than means what? It is yes, right? So you're skipping. If it's less than, you're skipping, which means it's a yes. If it's not skipping, which means it's no longer smaller than 5. So you go out. So which means skip if less than means here you're supposed to continue, right? Yes. So it becomes a bit easier in the sense that you can straight away continue, increase F, your task, increase your loop count, and then branch. If it's not less than, what you can do? Exit, straight away come exit. And this one will run for 5 times. So if you build this, let's clear all the memory. Six, seven. So this becomes actually both can work. Skip is greater than can, but skip if less than has a better structure. So how do you know when to use? Can I use skip if equal can? So how do you know which one is better? It's by trying. When you try, then you understand. Oh, this is for this kind of structure is better to use if it's less than. Especially whenever you're using a value from 0 and you're comparing with the loop limit, the less than, compare less than has a better structure. So you see it skips because it's less than, and increase the branch skips, and for now it's the 5th time. So when you compare now, 5, is it less than 5? No, so it will branch. It will not skip because it is not less than anymore. So you'll go out. So you loop for 5 times. This 5 times. Is that okay? Now before I end, I would like to show one of my personal favorite of doing the finite loop. So this is our task, right? This is our task. So the personal favorite is define, you have a loop count and loop limit, same. So what you do is, the first thing is you move the loop limit into working register, and then you load it into loop count. Is that okay? So this is your task, right? So I'll just delete all this. This part okay? Understand what we are doing? We are loading the loop limit into the loop count, and then we are going to decrease it. So, and then you have your task, and what do? You use this instruction decrease file register, skip if 0. So you are which file register that you are checking? Loop count. So FA. So skip if 0 means what? The content of loop count becomes 0, it skip, which means here let's say end of the loop. If it's not 0, what are you supposed to do? So where should the repeat go? To your task, right? Done. So what you're doing is you're sandwiching it. So I call this the sandwich loop. There's no such term. I'm a foodie basically, so I see everything in the point of food. So this is the top layer of your bread sandwich. This is your bottom layer of the sandwich. Basically this one, these two. And these two. In between the tasks, you can put whatever. So it will loop how many times you want. So this is my personal favorite. So again, I'm repeating. You load in your loop limit into your loop count. Do whatever task that you need to do. And after the task, what do? You decrease the file register. What is the file register you're decreasing? The loop count. Earlier you already put 5, right? So when you decrease, it will skip if it's 0. Skip 0 means going out of the loop. So if it's not 0, will it skip? No, it will go to the next line. So here you want to put branch repeat, or you can put go to repeat. And you can put the label where you want the loop to begin. So this is the sandwich loop, I call it. This is the bottom bread loaf, the top loaf. And in between you can put your how much of fillings that you want, how many layer you want, also no problem. So when you run this, so it becomes actually much more easier compared to any other loops. That's why I personally like this loop. So F6. Sorry, forgot to clear the memory. So let's see. So this one, you see, it's actually the loop count at address 00. It is actually reducing. Now it's reducing 2 times already. Now it's 1 time. Is decrease. If it becomes 0, it goes out from the loop. So this is one of the easier way of doing the loop. So any questions?